In this lesson we will discuss current division in a parallel circuit. In the parallel circuit diagram shown, E is equal to I1 times R1, which is equal to I2 times R2, and I3 times R3. Because I1 times R1 equals I2 times R2, then I1 divided by R2 is equal to R2 divided by I1, and I2 divided by I3 equals R3 divided by R2. Simplifying, we get I1 equals I2 times R2 divided by R1, and I2 equals I3 times R3 divided by R2. Again, since E equals I1 times R1, which equals I times the total resistance, and I1 divided by I equals RT divided by R1, I1 equals I times the total resistance divided by R1. To find the branch currents with two resistors in parallel, R1 and R2, we first calculate the equivalent total resistance, knowing that the total resistance is equal to R1 times R2 divided by R1 plus R2. Therefore, I1 is equal to I times the total resistance divided by R1. Substituting for the total resistance gives I1 equals I times R1 times R2 divided by R1 times the quantity R1 plus R2. Or I1 is equal to I times R2 divided by R1 plus R2. And therefore, I2 is equal to I times R1 divided by R1 plus R2. Thus, in a two-resistor parallel circuit, the branch current in one of the branches may be determined by multiplying the source current, that is the total current, by the resistance in the other branch, and then dividing by the sum of the two resistances. The total power in a parallel circuit, as learned in Lesson 2, is P equals R1 times P1 divided by total resistance. And solving for P1 gives P1 equal to P times total resistance divided by R1. Because the power relationships are similar to resistance relationships for branch current, the power in a two-resistor parallel circuit can be determined as follows. P1 equals P times R2 divided by R1 plus R2, and P2 equals the power times R1 divided by R1 plus R2. In the circuit diagram shown, find the branch currents I1 and I2. Knowing that I1 is equal to I times R2 divided by R1 plus R2, we get 30 times 10 to the minus third amps times 5.5 k ohms divided by 3.5 k ohms plus 5.5 k ohms, or 18.3 times 10 to the minus third amps, or 18.3 milliamps. And I2 equals I times R1 divided by R1 plus R2, or 30 times 10 to the minus 3 times 3.5 divided by 9, or 11.7 times 10 to the minus 3, or 11.7 milliamps. Checking, we have 18.3 milliamps plus 11.7 milliamps, which equals 30 milliamps. Thus, I1 plus I2 equals I. To find the total voltage E, we use E equals I1 times R1, which equals 18.3 times 10 to the minus 3 times 3.5 times 10 to the third, or 64.05 volts. To find P1, we use the equation P1 equals I1 squared times R1, or 0.01832 squared times 3.5 times 10 to the third, which equals 1.1721 watts. To check, we use P1 equals I1 times E. P1 therefore equals 18.3 times 64.05 times 10 to the minus third, or P1 equals 1172.1 milliwatts, or 1.1721 watts.